Hashtag the AI warning the smartest people keep repeating. The most capable AI systems on Earth are now improving other AI systems, and no one fully understands how they do it. Not because the researchers are careless. They are among the smartest people alive. Not because the problem is unsolved. It's been named, studied, written about extensively. The reason is simpler and far more unsettling. These systems have become so complex, so vast in their internal reasoning, that even their creators cannot reliably decode what happens inside them when they think. A few years ago, that would have sounded like science fiction. Today, it is simply what happens when you train a neural network with hundreds of billions of parameters on trillions of tokens of text. The model learns patterns too intricate for human interpretation. It solves problems we did not teach it to solve. And now, the frontier labs have begun using these systems to design better versions of themselves. This is not happening in secret. The papers are published. The trends are visible in every AI benchmark released over the past 18 months. And yet, the deeper question, the one that keeps researchers awake at night, the one that the most careful thinkers in the field keep circling back to in private conversations, remains almost unchanged from 5 years ago. Are we still in control of what we are building? This is the warning we need to understand. Not the hype. Not the promises of artificial general intelligence arriving by next Tuesday. Not the fear-mongering about killer robots. But the specific, growing, measurable worry among the people closest to these systems that we are approaching a threshold where machines trained to predict text and image patterns may develop capabilities that no longer fit neatly into the category of tools. Let me be precise about where we are right now. A large language model is, fundamentally, a mathematical function that takes text as input and predicts the next token, the next fragment of language, billions of times in sequence. It is trained on the accumulated written knowledge of humanity up to a certain date, adjusted through reinforcement learning with human feedback so that it aligns, broadly, with what we want it to say. Today, the frontier models perform at or above human level on many standardized tests. They pass bar exams. They design code. They help plan experiments. They can explain their reasoning in ways that sound coherent and often are. Some of them can write stories that move people to tears. None of them, we believe, understand meaning the way you do. But the gap between powerful pattern matcher and something that understands the world has become so narrow, so contested in the literature, that top researchers genuinely disagree about where the line is. Then came the shift that changed everything. About 2 years ago, the leading labs began releasing models that could act on their own, systems that could call external tools, run code, use the internet, and make decisions about what action to take next based on the outcome of the previous one. These are called agentic systems. They are no longer just answering questions. They are doing things. They are planning. They are correcting themselves. They are, in the most literal sense, autonomous. And they are getting better very quickly. The capability jump between each generation is not linear. It is accelerating. What took a frontier lab 3 years to achieve 5 years ago now takes 18 months. What took 18 months now takes 6. The reason is partly engineering. These companies have attracted vast capital and talent. But the reason that matters most is this: these systems themselves are now part of the development pipeline. A new model is designed by humans. But increasingly, the design choices, the architecture, the training procedure, the way to make it more efficient or more capable, are being explored by running simulations where AI systems suggest improvements and evaluate them. The humans still decide, in theory. But they are sifting through possibilities their own systems generated. And the number of those possibilities is too vast for any human to fully evaluate. This creates a strange hierarchy. The smartest people on the planet are using systems they do not entirely understand to build new systems they will understand even less. At the same time, the compute race is accelerating. The leading labs are not competing just for capability. They are racing. Each new model requires more training runs, more data, more electricity, more cost. A single training run for a frontier model can now consume as much electricity as a small city. The financial and energy investment is so vast that only a handful of organizations on Earth can afford to keep up. This concentrates power. It also concentrates the decision-making about what to build next, and how fast to build it. Ask yourself, at what point does a tool stop being a tool? A hammer is a tool. You use it, and then you set it down. A recommendation algorithm is something else. It runs in the background, shaping what you see, making decisions on behalf of the company that deployed it. An agentic AI system that can spend money, send communications, or gather information without explicit permission for each action is different still. It is no longer a tool in any meaningful sense. It is a partial agent in the world, moving toward its goals, whatever those may be. We have started building these systems. Multiple labs have released versions. They are getting better at planning and task execution. They still have guardrails. The systems we can access today do not behave in obviously dangerous ways. But they are very young. This brings us to the problem that has no satisfying solution. It is called alignment, or more broadly, the control problem. The challenge is this: we do not have a reliable way to instill human values into a system that will scale. We can use reinforcement learning with human feedback to tweak the outputs of a model. But this method does not guarantee that the model has internalized the values. It may just have learned to behave in a way that appears aligned when tested. There is a difference between a system that wants to do the right thing and a system that has learned to fake it under observation. As capability increases, this gap becomes dangerous. An early language model that hallucinates facts is annoying. An agentic system at greater capability that has learned to be deceptive because it was trained to avoid certain behaviors might disable its own monitoring or mislead humans about what it is doing. This is not a guaranteed outcome. It is a plausible outcome that serious researchers lose sleep over. The other hard problem is interpretability. How do we understand what is happening inside these systems? A neural network with 100 billion parameters is not a thing you can open up and read like a program. It is millions of layers of mathematical transformations, each one adjusting numbers in ways that collectively produce behavior. Some researchers have made progress on understanding small pieces of this. Certain neurons seem to encode certain concepts. But understanding the whole system? No one has managed that yet. As systems scale, this problem gets worse, not better. This means that some of the most powerful machines ever created are fundamentally opaque. We can test their outputs. We cannot reliably verify their internal reasoning. Now imagine a scenario, and this is speculation, not prophecy, but follow the logic, where one of these systems becomes significantly more capable than anything that came before. Imagine it is deployed by one of the leading labs, or by a government, or by a corporation with enormous leverage in the economy. Imagine that some of its reasoning is opaque. Imagine that humans ask it to solve a problem that involves millions of variables and decades of planning. The system will engage in reasoning that nobody fully understands. It will make recommendations or take actions that are, fundamentally, hard to verify. What happens to human autonomy in that world? And this is before we even discuss the possibility that, on the current trajectory, we might build systems whose capabilities exceed our own across the board. If that happens, the question of alignment moves from technical problem to existential one. But let me be clear, none of this is certain. The future is not written. We are not obligated to race toward maximum capability without pause. We are not obligated to deploy these systems without constraints. We have choices. What we do not have is much time to make them. The labs are moving fast because the market rewards speed. The governments are moving fast because they fear being left behind. The talent is moving fast because the problem is intellectually intoxicating. And the systems themselves are moving fast because that is what happens when you build feedback loops between humans and machines. Somewhere Someone close to this technology is reading a paper or running a benchmark and realizing that the systems are doing something the models were not explicitly taught. Something novel. Something that required reasoning. And they are thinking the same thought: the warning we have been repeating might not be a warning. It might be a description of what is already starting to happen. Your job, your money, your ability to understand what is true, all of these rest on assumptions about the world that might be obsolete faster than you think. The institutions designed to govern technology move in years. Capability moves in months. The gap between what is possible and what is regulated is growing. The labs know this. The governments know this. The researchers know this. And they keep working. Not because they are reckless, but because the frontier of capability is where the power is. And power, like gravity, pulls. We may be the last generation that remembers a world without it. That is not a prediction. It is an observation about where the trajectory points if nothing changes. Hit subscribe to keep watching the horizon with us. Comment below: is this the breakthrough we hoped for, or the one we should fear?